Please see the video till the end. Now we will learn about addition of like fractions. First I will explain you with one example the concept. Here one strip is divided into 5 equal parts, and what I will do, I will out of those 5 parts I will color the 3 parts. I will shade it with some colored chalk. So if you are asked that show the shaded portion in terms of a fraction, so this whole part is divided into how many equal parts? 5. So denominator will be 5. And shaded part, how many parts are shaded out of those 5 parts? 3 are shaded. So 3 upon 5. So you can show that shaded part as 3 upon 5. Now, but 3 upon 5 means what? I can write this 3 upon 5 as 1 upon 5 plus 1 upon 5 plus 1 upon 5. Means here the denominator remains as it is, only the numerators are added. Means 1 upon 5 plus 1 upon 5 plus 1 upon 5 becomes 3 upon 5. When like fractions are added, the denominator remains as it is. The common denominator, we write it as it is. We don't add the denominator. Only we add the numerators in case of like fractions. Suppose one more fraction is there. 2 upon 7 plus, if you are told to add these fractions, 2 upon 7 plus 5 upon 7. Fractions are like fractions because their denominators are same. So how you will add? You will keep the denominator, common denominator as it is, and you will add only the numerators. So 2 plus 5, 2 plus 5. So 2 plus 5 is again 7. So 7 upon 7 will be the new fraction. Now here one more concept we are going to learn, that what is the value of the fraction when the numerator and the denominator is same. In such cases, if the numerator and the denominator of any fraction is same, whatever it is, let it be 41 upon 14 or 102 upon 102 or 2 upon 2, the value of such fraction is always 1. If the numerator and the denominator of a fraction is same, the value of such a fraction is always 1. And when the like fractions are added, we keep the denominator as it is and we only add the numerators. I will explain you with one more example. 2 upon 5 plus 1 upon 5. Add these two fractions. Now you know that these two fractions are like fractions. Their common denominator, you keep it as it is and only add the numerators. 2 plus 1, 3. So 3 upon 5. Very simple. If you add the like fractions, that is the fractions with same denominator, keep the denominator as it is and only add the numerators. And after adding the numerator, whatever new numerator you will get, so that numerator upon the denominator, which is a common denominator. I hope you understood how to add like fraction. That when the numerator and the denominator of a fraction, when the numerator and the denominator of a fraction is same, suppose 41 upon 41, 2 upon 2, 5 upon 5, means the numerator and denominator are same, the value of such fractions is always 1. Means 41 upon 41 is 1. 2 upon 2 is 1. 5 upon 5 is 1. I'll explain that you with one figure. Suppose, let us consider this is chapati. And I have made 4 equal parts of this chapati. Or say, first I will make only 2 equal parts of the chapati. And I will shade one part. This shaded part, I am giving it to Pawan. Okay, say Pawan. We are giving this shaded part to Pawan, means how much part of this chapati we are giving it to Pawan. We are giving, the chapati is divided it into 2 equal parts, and out of that we are giving only 1 part to Pawan. That means we are giving half part to Pawan. Okay, now what I will do, Pawan is asking me for more. So, what I decided, I have divided this chapati into 2 parts. So, I felt that I will give both the parts to Pawan. So this chapati is divided into 2 equal parts, and out of those 2 parts I am giving 2 to Pawan. Means, am I giving full chapati to Pawan? Yes. So that means I am giving 1 full chapati to Pawan. So I hope when the numerator and the denominator are same, the value of such a fraction is 1. And even while converting the fractions into equivalent fractions, there also you saw that when the numerator and the denominator are divided by the same number, same divisor. Suppose I will divide this 2 denominator by 2 and numerator also by 2. So 2 divided by 2 is 1, and 2 divided by 2 is also 1. So here numerator and denominator is same, so the value is 1. And one more thing, suppose this 1 here is not having a denominator. So here the denominator is always 1. The number which is shown, suppose 5 is shown, and it is, the denominator is not shown, it is always 1. We don't write it, but suppose only the number is there, we can write its denominator as 1. 5 can be written, it means 5 can be written as 5 upon 1 also. 7 can be written as 7 upon 1 also. Means because 7 divided by 1 is 7. So if there is no denominator, it is understood that it is 1. We don't write it. Okay. So I hope this concept that when the numerator and the denominator are same, the value of such a fraction is always 1. Subtraction of like fractions. One example I'll take. 4 upon 7 minus 2 upon 7. We saw addition of like fractions. In the same, the methodology is same for the subtraction also. The method is same. Only here it is subtraction, there it is addition. The fractions are like fractions here. I again repeat, like fractions means the fractions with same denominator, common denominator. Now here what we do, you know that in addition of fractions of like fractions, addition of like fractions, we write the denominator as it is. Here also we write the denominator as it is in case of subtraction also. But instead of addition here, only we do subtraction. 4 minus 2. So 4 minus 2, we will find the difference here, and 4 minus 2 is 2. So 2 upon 7. So only the difference is, instead of addition we are doing subtraction here. The rest of the things are same in case of addition of like fractions and subtraction of like fractions. We keep the denominator as it is, and only we subtract one numerator from the other, and we write the difference here. 4 minus 2 is 2, so 2 upon 7 is the answer of this subtraction. So subtraction of fractions, I hope it is clear.
Dear viewers, if you feel that this teaching video is useful to you, please like it and subscribe to my YouTube channel. And also please do share it with your friends and relatives who have students in their families. Please feel free to give suggestions and feedback. Do leave a comment for the same. Myself, Mr. Dinesh Kadu for Maths Enjoyment YouTube channel. Have a good time.